On numbers 13 through 15, we have to solve the trig equations and make sure that we identify all possible solutions. First thing you want to do is isolate the trig function, and it's good to keep the unit circle handy for this so that you can figure out which angles fit the equation that you end up with. So in order to isolate the trig function on this one, we would want to start by subtracting 14 from both sides, and then we would want to divide both sides by 4. And then square root both sides. Now square rooting does mean that we have to put a plus or minus in front of our solution, which means that this is going to have 4 different solutions, all the different spots on the unit circle that show a sign of root 3 over 2, positive and negative. The directions say that you can show your answer in degrees or radians, so for this one I'm going to go ahead and show the answer in degrees. And there's our solutions that match with those 4 spots on the unit circle. On number 14, the equation is set equal to 0, and I can see that both my terms have a sign x, so this is one that's set up to be good for solving by factoring. So the first thing I'm going to do is pull a sign x out of both of those terms, and now that it's in factored form, I can go ahead and set each factor equal to 0 and solve those 2 equations separately. With sin x is equal to 0, there are 2 spots on the unit circle that correspond with that equation. And I'm going to go ahead and express my answer in radians this time. We've got pi plus 2 pi over n and 2 pi plus 2 pi over n. You could also just write that as 2 pi n, and that would mean the same thing. That would be as if you were treating it as 0 degrees or 0 radians instead of 2 pi radians. But really only these guys are necessary for your solution. Then I'm going to go ahead and move to the other equation, and I need to isolate the trig function first, so I need to subtract 1 from both sides, and then divide both sides by the square root of 3. And so I'm looking on the unit circle for a tangent of negative 1 over root 3. And of course the tangents aren't shown on the unit circle, so it might be handy before the test to go through and calculate all the tangents and write that on your note card, or just know that you need to set up a fraction where the denominators match, and you need to end up with 1 in the numerator and root 3 in the denominator. We're also looking for a negative tangent, which means our answers either have to be in the 2nd quadrant or in the 4th quadrant, where the x and y's have opposite signs. So there's 2 spots on our unit circle that matches with, and here are the radian measures that would match with those spots on the unit circle. A good way to start solving this equation would be to go ahead and square both sides in order to get rid of the square root on the right hand side. And I'm going to go ahead and start expanding the left hand side at the same time. This is a pattern I've already seen a couple times while working through this practice test, and so I know that this expands to sine squared plus 2 cosine sine plus cosine squared, and that embedded within that expansion is one of our Pythagorean identities. Sine squared plus cosine squared simplifies to just 1. And so now I can rewrite this as 1 plus 2 cosine times sine is equal to 2. And I want to try and isolate those trig functions, so I need to subtract 1 from both sides. And if you're familiar enough with your formula sheet, what we're looking at right there is actually the formula for the double angle of sine. And so I can condense that down into one trig function by using that double angle formula instead of keeping it in terms of cosine and sine. So now I can rewrite my equation as sine 2 theta is equal to 1. And that means that I need to look on my unit circle for all the places where the sine is equal to 1, and there's only one spot on the unit circle where that happens. So 2 theta is going to be equal to 90 degrees plus 360n. Don't forget to put that plus 360n before doing your final step to solve for theta, which would be to divide both sides by 2.